Okay, so work and power practice. Imagine pushing a grocery cart with a constant velocity. In each scenario, describe the force, work, and power of the situation. As you put things in the cart, explain how each variable changes. If it does not change, explain why as well. So, grocery cart, going to the grocery store. As you put things in the cart, does that change the applied force? Yes, it does. Because the more mass it has in it, the more inertia it has, the more force it takes to get it to go moving. So, yes, this will increase the work done. Well, work is force times distance. If I increase the force applied, there will be more work. More work because there's more force. What about the power being used? All right, well, power equals work divided by time. Assuming that you're going to keep moving at the same speed and not be slowing down, then yes, you will definitely be doing more power because you're doing more work. Okay, number 2. So now that you kind of have an idea of how to do it, I want you to pause and attempt. All right, pause and attempt questions 2, 3, and 4. Once you've made that attempt, then undo the pause and check your answers. Okay, so if you walk down every aisle in the store, rather than just the few aisles you need, however, if walking at the same speed and buying the same items. Okay. So if I walk down every single aisle in the store, so back and forth, every single aisle, my distance traveled, definitely more. All right, it increases. So if my distance travels increases, then I'm doing more work. Even if I put the exact same things, even if the amount of force I had to push in the cart is the same, I'm doing more work because there's more distance in this situation, because work is force times distance. The force is the same because I'm buying the same items, but I'm walking more distance. Power used. Well, if we're doing the same speed, the same items, walking down every aisle, okay? In this situation, because it's the same speed and the same items, remember I showed you how that power is the force applied by the speed? Okay? If the speed stays the same and the force stays the same, then it's going to be the same amount of power. Okay? Because the increased time and the increased distance traveled increase together, resulting in a same amount of power. Okay? While you're standing waiting for the cashier, describe your work and power. So, if I'm standing waiting for the cashier, my distance traveled? 0. I'm not moving. Oh, key concept there. If I'm not moving, there's no work. If there's no work, there's no power. All right, question number 4. After paying, you walk with the full cart to the door. It's raining outside, so you decide to run, pushing your cart to the car. What changes? So the force applied, okay? The force applied, because we're dealing with friction here, the faster you go, the greater the friction. So we will have more friction, more force, because there's more friction because you're going faster. Okay, so the work done, if I've increased the work, yes, so it's increased the force, there's more because there's more force. Power used, definitely more because we have more force and we're going faster. So there'll be a lot more power involved. going through the parking lot. All right. Now for the calculations. So with the calculations, problem-solving process, show your work. Show all your work. Okay? So show your work. I'll do the first one with you, and then I want you to pause for each one. Push a 45 newtons. Push the 45 newtons on a box to move it 120 meters in 96 seconds. Question is asking for how much work was done. Newtons measures force. Meters measures distance. Seconds measures time. You need to know what those measure. Otherwise, you can't do that part. If you can't do that part, you can't pick your formula, you can't move forward. So you have to be able to know that newtons measures force, meters is a measure of distance, seconds is a measure of time. Work is the question. We have our three formulas here. Okay, I have this power is work over time. Well, I have time, but I don't have power. All right, I have work is force over force times distance. I want work, I have force and distance, so that's the form I'm going to use. Work equals force times distance. Since work is the question, I don't need to rearrange, I just plug in my numbers. Force, 45 newtons, multiplied by distance, 120 meters. Punch that into the calculator. Calculator says 5,400. Sig figs, 2, I need 2. It gave me 2, so I don't need to do any adjustments. 5,400 units of measure for work, joules. That's your answer. Okay? Go ahead, pause this video and attempt number 6 on your own. If you're getting stuck, notice that we're talking about question number 5. So this box, all of this data applies here. So your 45 newtons force, 120 meters distance, 96 seconds time, all applies. But you also now know that the work, 5,400 joules of work was done. You can add that to your data. Figure out number 6. Okay, so the question is asking for power. Power is work divided by time. We have those two. Since power is the question, don't need to rearrange. Work, 5,400 joules divided by 96 seconds. Calculator says 56.25. Significant figures, 2 significant figures, so 56 units of measure for power, watts. 56 watts. Number 7, again, pause and attempt. Okay, your friend applies 657 newtons onto a cart and moves it 39.1 meters in 15.7 seconds. All right, question is how much power was generated by your friend. Newtons measures force, meters measures distance, seconds measures time. All right, so my formulas, I have the formula power equals work divided by time, but I don't have work. I have work is force times distance, that doesn't have power in it, so that doesn't help. Power equals force distance divided by time, power, force, distance, time, bingo. All right, so my power equals force times distance divided by time. Plug in my numbers, 657 multiplied by 39.1 divided by 15.7. You can actually put that in the calculator right as it is. You can actually put those into you can actually punch those in the calculator just as they appear, and you get your answer. Calculator says 1,636.22293. Significant figures, I've got 3 significant figures in all of those numbers. 1, 2, 3. The 6 is going to round the 3 up, so 1,640 units of measure of power is watts. Okay, so we have a 25 kilogram lawnmower doing 347 watts at 9,514 joules. Okay, so kilograms measures mass, watts measures power, joules measures work. Question asks, how much time did the lawnmower run? Well, look at my formulas. Power, work, time. Mass is unnecessary, unneeded. So go ahead and power equals work divided by time. Time is the question, but we need to rearrange the formula. Time is equal to work over power. Okay, work over power. Plug them in. 9,514 divided by 347. 9,514 divided by 347. Calculator says 27.41786. Significant figures. We've got 3 significant figures. That one, 4, so 4 here, 3 here, so 3 significant figures for answer. 27.4 units of measure for time, seconds. Okay. Pause the video. Attempt to answer the question. Problem. Okay. 741 joules. 2.83 meters. Joules measures energy or work. Meters measures distance. Question is the weight. So you have to ask yourself, weight. What's the formula symbol for weight? FW. Now if that helped, go ahead and pause and correct your answer or fix it. All right, if you got that far, then you should have been able to figure out from here what to do. So, work, distance, force. Work equals force times distance. Force is what we're solving for, so rearrange the formula. Force equals the work divided by the distance. 741 divided by 2.83. Calculator says 261.837. Significant figures, 3 sig figs in both of those numbers. So 260, 261, the 8's going to round the 1 up to a 2. 262 newtons for force. Number 10, pause and then attempt to solve it on your own. Okay, 35 kilograms measures mass, 92 joules of energy or work, 45 newtons measures force, 74 seconds measures time. Question is asking for how far, which is distance. So my formula that has distance in it, the only is this one, work equals force times distance. But I've got work and I've got force, so distance should be easy to solve for, so the mass and time are extra information. Work is force times distance. Distance is the question, so I need to rearrange the formula. Distance is work divided by force. Distance is work divided by force. Plug in 92 divided by 45. 92 divided by 45 gives us 2.044444 on forever. Significant figures, 2 sig figs, 2.0 distance meters. Okay, number 11. Attempt it on your own. Pause. Okay, working through the problem. 105 meters, 28 seconds, 81 watts. Meters measures distance, seconds measures time, watts measures power. Question is asking for how much work. Work is the question. Well, work is force times distance, but I have distance, but I don't have force. But power is work divided by time, okay? Power is work divided by time. I've got power and time, want work, we're going to use this formula. Okay, so power is work divided by time. Work is the question, so I need to rearrange the formula. Work is equal to P and T side by side, power multiplied by time. So I'm going to take the power of 81 watts, multiply it by the time of 28 seconds. 81 times 28 gives us, calculator says 2268. All right, 2,268 significant figures, 2 sig figs. So to the 2, the 6 is going to round it up. So 2,300 joules for work. Okay. Question number 12. We're stepping it up a notch. This is going to be much more challenging. So give it an attempt. When you get stuck, come back. So pause. Okay, setting this problem up is very important. 284 newtons. Newtons measures force. 8,492 watts. Watts measures power. 305 meters. Meters measures distance. Question is, how long did it take? It's asking for time. You got that far? Good. Now, you're probably like, time. Well, time, okay, that formula is time and this formula is time. But it's not solving for time, and rearranging that unless you have awesome algebra skills might be a little challenging. So we don't need to rearrange that formula. We can use two formulas. So start with this one. Power equals work over time. Time is the question. So rearrange this formula to solve for time. Time is equal to work divided by power. Okay? But we have the power, but we don't have the work. But we do know that work equals force times distance. And we do have force and distance. So we're going to first use this formula to solve for work, then plug into that formula to solve for time. So work is force times distance, force of 284 newtons multiplied by a distance of 305 meters. So we have a work. All right, so that going in right there is going to be 86620 joules. 86,620 joules of work. And then divided by the power, okay? So you're going to end up with time is the work divided by the power, 86620 joules divided by a power of 8,492 watts. All right, time. We divide those two, you get significant figures. So the calculator says, calculator says 10.200188841, whatever. Okay, sig figs.
John and Lee Fernandez, please report to the front office. John and Lee Fernandez, please report to the front office.
This is what the calculator gives us. Significant figures, we need 3 significant figures. That has 3, that has 4, that has 3. So 3 significant figures, the 1, 0, and the 2. 0 after that does not round it up. So 10.2 time measured in seconds. 10.2 seconds. Okay, number 13. Similar to number 12, you're going to have to use two formulas. Give it a shot. "95 newtons. Newtons measures force. 780 watts. Watts measures power. 23 seconds. Seconds measures time. Question is, how far would you go? That's distance. Okay? So again, this formula has all those formulas, has all together because it's two formulas combined. But unless you have the algebra skills to rearrange it, you're going to have to break it down into two separate formulas. Okay? So, distance. Well, we'll have to find out this. Work is force times distance. Rearrange that. Distance is going to be equal to the work divided by the force. And then that work, okay, we know power and time, so power equals work divided by time. If I rearrange the formula to solve for work, then work is equal to power multiplied by time, P multiplied by T. Multiply those two together, and then we'll plug it into that formula. So let's do this first. Power 780 times a time of 23 seconds gives us a nice big number, 17,940 joules of work. And then I'm going to plug that into this formula with the force. So that distance is going to be the 17,940 joules of work divided by a force of 95 newtons. To get us calculator answer of 188.842. Significant figures, I've got two significant figures. So two significant figures. So 188 rounds to 190. Distance, meters. Okay? So go back through any problems, check them out. Hopefully that was helpful for you.